Yeah, it's interesting to hear for most people that you didn't include salmon and any of the other smash fish in your list.
Yeah, so the high fat fish are very high in polyunsaturated fats, specifically omega 3s. And we can, you'll have to let me know how deeply you want to dig into omega 3s. But the short answer there, the short kind of story there is everything that we're concerned about when it comes to omega 6s is worse with omega 3s. Omega 3s are very similar to omega 6s, except they have extra double bonds, and therefore they're even less stable. So they're more susceptible to damage, to oxidation, or peroxidation, not only on the shelf in a fish oil capsule or in the in the pan if you're cooking salmon, but also internally. That's really the concern with these fats is how easily they're damaged internally. Also,
Yes.
when they're used for structural purposes, they're used just as inefficiently. And this is something that is not talked about quite as much with the omega 6s, but the fats that we consume get incorporated into the every cell in our bodies. And we want to have very stable cellular structures, right? The walls and the kind of separations, what are called membranes in the cells, are all made up of fats. And the more unsaturated those fats are, the leakier they are. And generally, leakiness is not a good thing. One place that it's especially a problem is in the mitochondria, in the engines of the cells. Basically, in order to produce energy, we create a gradient. It's an electrochemical gradient that allows for us to create potential energy that allows us to produce ATP. You can kind of think of it like a hydroelectric dam where we pump a lot of water to one side and then push that water through one specific area that spins a wheel or turbine or something that allows for energy to be produced. We do something very similar inside our cells, inside our mitochondria, and the wall is made up of fats.